So thank you everyone for coming. I hope you've enjoyed Youth for BEF so far. My name is Rand and I will be your moderator today. I'm from the SEG 7 Youth Constituency, and today we are very happy to have with us Bilal, who is joining us from Pakistan to present a Nordex wind turbine virtual tour. So he will explain the basics of wind turbine and then introduce Nordex. After that, he'll show us around an actual wind turbine that is simulated in a video, and then actual footage from inside a wind turbine explaining what each bit does and how it works. So the video recorded visit is the N117 Delta 3K turbine, which is in the Kiyikoy WP project in Turkey. Quick housekeeping rules. So you may ask questions at any time during the virtual tour. To ask your question, either write it in the chat, in the Q&A, or you can ask to turn on your video and your audio and you will join the session. And once I give you permission, you can ask your question live. So if you have a question, either request permission to join or write it down and I will read it for you and interrupt Bilal. Please, once you finish your question, leave the floor because we can't have too many people with their video on at the same time. And just don't hesitate to participate. This is supposed to be an informal and interactive session, and it's a really unique opportunity to see how it goes on inside a wind turbine. So I hope you enjoy it, and I'll give the floor to Bilal.
Okay, thank you, Rind. Thank you for the introductions. Hello, everyone. My name is Bilal Hassan Khan. I'm from Pakistan, basically, and I'm here from the forum of the Nordex. So Nordex is one of the top wind turbine manufacturer in the world. And today we are going to visit one of the Nordex products. Today we are going to visit, and this is an opportunity for all of us that we can virtually visit the turbines, as we are not able to directly visit. So I have some, as Arvind has already shared, that I have some videos, simulators, so we will go through them. But before starting a virtual tour, I would just explain you some of the basic knowledge about the wind. Then we will start our sessions. So first, I'm sharing my screen regarding my small presentation, which will give you a small basic knowledge about the wind. And then we will start for our session. I hope you all can see my screen, right? Right, Rinde?
On my side, it's good.
Okay, that's really good. Okay. So when I talk about the wind turbines, so first things come in my mind is about the wind. So now we think that how the wind developed, how wind develops. So basically, wind is a flow of air. Wind is a flow of air. And in air, we have too many molecules, too many gases, and all of those gases, when travel from one location to other location, this movement we call the wind speed. Why this movement happen actually? This is because of pressure composition between high pressure area and the low pressure area. This is the basic thing, how wind started to move from, how air started to move from one location to other locations. And what happened that when one area is high pressurized with the air and the second is low pressurized with the air? As you can see in my screen, we have a land. We have the countryside and the land, and the other side is the water. So land has a special thermal capability than other than water. Land can be hotter quicker than the water, and also land can be cooler earlier than the water as well. So in the sunshine, when the sun is shining, the land become more hotter than the water, and the air molecules on the land side, it start to go up. It become lighter and it started to travel to upside. As you can see here, the warmer air is going upside, and the pressurized air on the seaside is start to travel from the countryside, and we call it the sea breeze. The wind is coming from the seaside, and this is happen oppositely in the night time actually, when the land become more cooler than the water, and the wind start to travel from land side to water side. But there are many other factors as well which can reflect the wind speed and the direction, the movement of the earth as well. But at the basic, we have enough information about this for the basic learning, that wind is created because of different pressure compositions. But now we know that wind is created due to the different kind of pressure compositions, but how we are utilizing these kind of winds, how we are utilizing. So we are utilizing the wind since many years, since maybe more than 2000 years we are utilizing this wind for different purposes. We are utilizing wind for different purposes, but right now our topic is talk about the wind turbines and the modern wind turbines. Actually, we are also the old people were also using the wind speed for different purposes, but for the mill, different kind of mills. But right now we are talking about the wind turbines which give us the electricity. The basic structure of the wind turbine, the basic purpose of the wind turbine is to convert the kinetic energy, the wind energy, to convert into mechanical energy, and then it shift to the electrical energy. So how it's worked that in we will learn about that. We have a rotor which face the wind speed, and then it's transfer the rotating speed to the gearbox, and then gearbox increase the number of turns, and then we have a generator which convert our mechanical energy into electrical energy, and then we have a converter system in our turbines which I will show you in this session, and we have a transformer, and with the help of that transformer we feed our energy to the system. There are some output related the performance of the wind turbines. The energy volume of the wind is depend on the wind speed and air density. We know about the wind speed, but if someone has a confusion regarding the air density, so I would explain here. Air density is a volume of the air molecules in a specific area, so we call it the air density. And our turbine performance is directly affected by the wind speed as well as the air density. So for example, if we have a same wind on different location, and if you have one location we have a high air density and other is we have a low air density, so our turbines where we have a high air density will produce more than the low density area. Also, the rotor diameter, the size of the blade, and the surface area covered by the blades will also affect the performance of the turbine. And one more thing which affects the performance of the turbine is about the power coefficient of the wind turbine. It is the design of the blade and rotors. So this it's also affect the turbine performance as well. Now we talk about the basic structure of the wind turbines. So basic structure of the wind turbine is that we have a rotor, the rotating part of the turbine. Rotor consists of 3 blades and 1 hub. Then we have a nacelle, and then we have a big tower and foundation. So we'll talk about all these things separately one by one. First, let's talk about the tower. You can see there are many different type of towers where you will see the wind turbines. You will find that there are many type of towers. The steel grating tower, tubular steel tower, wooden tower, and hybrid tower. But currently, the most popular tower which are being used in the wind turbines is the tubular steel tower. But we are also using the hybrid tower, the combination of the concrete tower and the tubular steel tower. But mostly these kind of hybrid tower we are using where we have a high, where we are using the taller tower, like more than 100 meters. So we are using them. Otherwise, the most common tower we are using the tubular steel tower. Flexibility tower heights are the key factor when we discuss when we talk about that. If we have a land near to the city, and we have a very high taller buildings in the city, and those buildings can affect the wind speed, also the performance of the wind. Like we will receive after that the disturbed wind speed on that area. So in that area we can use a taller tower, because when we increase the height of the tower, we will receive a undisturbed wind and that height. So this is also good option that if we have any area where we have too many obstacles on the ground, then we can use a taller tower. And this is an option. We can use the same nacelle size, same rotor side, but we can increase our tower. So this is also an option we have in Nodex. After the tower section, let's talk about the rotor. Actually, rotor is basically consists of 2 parts: blades. We have 3 blades in the rotor, and the center thing. Here we have a hub, the center one. In hub we have a drives. Each blade has independent drives, and those drives controlled by different independent converters. We have each blades has independent drives, and each drive has an independent control unit and backup supports in our turbines. We will see everything also in our visual tour. I'm just explaining the basic things here, and after that we will, when we go for the visual tours, we will see all the things separately. So Nordex has a many different products, and I will tell you about those products right now. But this I add this picture here. This is about a nacelle which we are going to visit today, actually, because we have a different kind of products in Nordex, and some product, the basic structure of all turbines is same. Actually, we have a drivetrain, we have a main drive, main bearing, we have a gearbox, and then we have a generator. Basic structure actually is the same one, but there are some changings, small changings, like, so we have a three, you can see in this picture we have a different box, three boxes, but in other turbines maybe we have four boxes, and we have a transformer inside the turbine. So there's not much difference, but there's some kind of small differences in each product. And we will see the same product in our visual tour today. We will see the same one. As I mentioned here, that Nordex is creating many different kind of products right now, and almost now in today's market we are offering just two products right now, because most of them has obsolete, because they were on the working on the old technology. But now we have a new technology, and these two projects are Delta 3K, Delta 3000 model, and Delta 4000 model. Delta 4000 model are the newest model. And what are the specialties about this model? Normally, previously, when we have a wind turbines, we have to create each turbine according to the wind class. IEC standardized some classes for low wind area, for high wind area, for medium wind area. And previously we were producing the product according to the wind class. But now Nordex has started to produce the product which can fix on all wind classes. If you have low wind area, you can install that product. If you have high medium wind area, you can install that product. And if you have a strong wind area, then after some modification, we can also install that product as well. So we have a different kind of product, and we are making flexible product for each site. Also, these product, previously we were producing the product which is only for the hot climate version, and some product for the cold climate version. But these product are really flexible, and we can install this product even in the minus 30 degrees centigrade, the coldest area, and maybe more than the 50 up to 50 centigrade, the hottest area. So these products are more flexible, and either we can use these product on the ground level or on the mountain. So these are the really efficient model. And what are the good benefit from these model as well? That while engineering were creating this product, they also focus on the production, because during the production they think about the less maintenance. So in the new product, we are doing very less maintenance. Like we have finished almost 90% maintenance have skip, and we are only doing the 10% maintenance, because we call that those turbines are maintenance free almost. And in this steps, I would like to show a small video regarding the technical evolution of the Nordex. So I'm just going to start this this video here, and let's watch together. Ren, I think you can hear the voice of the video, right?
Can you play a bit more, because no, I can't hear any audio.
You cannot hear any audio. Okay. Now can you hear?
Yeah, all good.
All right, everyone. So you have watched the technical evolution of the Nodex. And what was the most interesting thing about this video? Actually, I would say that if you have seen let me open this again. Okay, this one. Normally, when we create a wind turbines, previously maybe this is the old turbine, maybe 27-year-old turbine. So when you develop and create a new turbines, right now we are thinking that the turbine can long last 20 years. And then maybe we are considering that maybe 25. Now we are making the new technology and we are considering that this turbine can run for 25 years. But this is really good thing about the Nordex turbine, that these are the old turbines, maybe 27-year-old turbine, and they are still producing. And it's reflect the maturity of the product. So after 27 years, old turbines are still producing. This is what I like most about this video. Okay, so it was the short introduction about the Nordex. So I think we should start here our virtual tour. And before starting the virtual tour, I just put some information here. Actually, this information has already shared by the wind. That's the location is Kırıkkale. It's near to the west north Turkey, and the project name is Kiyekoe. And the turbine models here we installed is N117 Delta, which we are going to visit this turbine. This turbine rated power is 3 megawatt, and the whole project is about 45 megawatts. So we are going to visit this project right now.
Bilal, we have some questions before we go to the virtual tour.
Sure.
The first question, there's a comment, very interesting presentation, thank you. And then the question is, what do you think is the maximum size wind turbines can have?
Maximum size?
Yes, what do you think is the maximum size wind turbines can have?
Right now? Or Nordex? Nordex has a 5.8 megawatt up to 5.8 megawatt turbine right now. Actually, as I told that this is the flexible model, so I go back again. Okay, this is the 5 megawatt plus models, Delta 4K, and these turbines can produce more than 5 megawatts, and the maximum rating is 5.8 actually. So we have a model which can produce 5.8 megawatts till now.
Okay, we also have another question from Jaldin Beari. I'm sorry if I mispronounced your name. What is your opinion towards using other types of wind turbine, like vertical axis wind turbines? Also, towards using Archimedes wind turbine, how promising are they? And what are the obstacles facing them in the large scale?
They are different kind of wind turbines designed, the vertical and horizontal. Why we are using the horizontal wind turbines? Because of the efficiency. There are big difference. You can use the other turbines as well, but when we compare the efficiency, so it could be nearly about 30% and 100%. The vertical wind turbines can produce up to 30% if give you 30% efficiency, and when you talk about the horizontal turbine, they give you 100% efficiency. So efficiency is too much difference in the efficiency and production. So yes, if you have you can use the vertical turbines as well, but you will face the proficiency issue, and it will not produce as the horizontal can produce. And there are some other challenges. Other challenges. Also, there are many challenges as well in the horizontal turbines, because in the vertical turbines you don't need to install the yawing system, but in the horizontal turbine we need a yawing system, big yawing system. But of course, at the end, when we talk about the efficiency comparison, horizontal turbines has a much higher efficiency than the vertical one. So of course, if you go for the efficiency, we have to use the horizontal one.
Okay, Bilal, and then we have another question from Fidele Gisore. He says, I'm from Rwanda. What are the criteria for a country to harness wind power?
What are the criteria?
Yes, for a country to harness wind power, maybe, for example, there's a certain wind speed they should have, available space.
Okay, you are talking about like this. Okay, so actually, when we started to install the wind turbines, and we have to perform a topography survey of the land before installing, because in 2012, in the first time when wind turbine come in Pakistan, so initially we have installed only 5 turbines. And it was a testing period, and we want to test the results. We have installed only 5 turbines because there are we had a wind here. We performed the topography survey here, and we found that we have a good wind. Annual wind is around 7 to 8, and we believe that it's the moderate wind speed, and we can get from this good amount of energy. But there are also other factors as well in some countries, like in Pakistan we have some kind of security issues as well. And also initially when in Pakistan there was no wind turbine initially, someone has to get a step first. So there is a company, the Turkish company Zolu, who installed initially 5 turbines. And then when we received that, oh, there was a good result from that company, and after one project, one for only 5 turbine project, it was a 5 megawatt project only, and then other companies started to install. Until now, maybe more than 25 companies has installed the wind turbines in Pakistan within 7 to 8, and there more are coming. Well, so this is all the different security aspect, but also there are some other aspect like a wind speed. We have to select the site where we have good wind speed, and also there's a talk about, we also check the land if it is easy to install in that land the wind turbine, because sometimes creating a foundation is really critical as well. So there are many surveys, and we call them the topography survey in start, and it take almost 1 or 2 years to finalize the location. And actually, and also after the topography survey, you have to select your turbine model, because as you know, I have mentioned that I have different kind of models, and you have to select the best model according to your location. You have to select the best one, because in a starting good selection, you will get the good energy. If you will select the wrong product, then you will not produce as much as it should be on this location. So first we have to make a topography survey. By the help of that topography survey, we took the enough information from that survey, and after that we selected the turbine model from different companies. It could be a Nordex or any other company as well.
Thank you, Bilal. So basically, to summarize, there are topographical factors related to wind or land, but also social or political issues with security. So it's a complex thing, and there should be studies to determine if.
Actually, yes, just want to add here, because we have also very much land available in Pakistan where we have a good wind, but due to some security issues, we are not able to install their wind turbines. So it is also a matter to install in any country. If you want to install the wind turbine, you have to also focus these factors as well, rather than the wind speed only. Yes.
We can go back to the tour.
Okay, that's good. Okay, here. So I start here our tour. Okay. I believe all you can see my screen, right?
Yes.
Okay. As I mentioned that we are going to visit a wind farm. This is called a Kikoe wind farm, and the capacity of this wind farm is 45 megawatt. And in that wind farm, we have a 15 Delta 117 turbines. 15 Delta 117 turbines. We have to make a small video for you to do this virtual tour possible, and then we can see that here we have a substation, a grid station. Someone call it a grid station as well. So all turbines are connected with the grid station, and in this grid station we have a SCADA system. A SCADA system can control all the turbines together as well, and we can also control each turbine individually. So this is a SCADA system, and all turbines sending the supply to the grid station, and then the grid station is connected with this transformer, and this transformer is connected with the network. It could be a power purchaser network who is purchasing the power from the customer. So this is a small view of the substation of that project. Now let's go to the turbine directly. So now we are reaching on the turbine, and it is important factor regarding the safety that whenever you visit the turbine, it's important to park your car opposite direction of the wind turbine, because it's an instruction from the HSE, because in case of emergency you can run fastly. So you have to park your car, and your car direction should be opposite of the turbine. Before entering inside the turbine, you have to use some kind of PPs. Actually, there are some basic PPs. It could be your shoes, it could be your dress, and these are the basic PPs: shoes, dress, and helmet. And if you just want to visit the bottom platform on the turbine, you don't need to wear other PPs like full body harness, and you don't need a lanyard, and you don't need the fall arresting system. But if you want to go in the nacelle, then you need a full body harness, and then also you need the other component as well, the safety lanyard, and you have to use the positioning rope and other equipments. You have to use them as well. This is really important before entering inside the turbine. There are some internal procedure of the Nordex, which is here. Before entering the turbine, you must have to stop the turbine first, and the second is we have a procedure man on turbine. For example, when you want to insert the turbine, you have to inform globally that someone is working on that turbine. So nobody remotely start or do anything on that turbine, because everyone knows that someone is working when you apply the man on turbine. This is a Nordex internal procedure to tell everyone that someone is working on that turbine. So okay, now the two technicians are inside the turbines. Then let's go with them together. Okay, when you insert the turbine from this gate, you will see there are some panels here. I go back and show you the panel picture from different views. Okay, when you come from this gate, and there's some panel in front of you. There are two kind of panels here. One is belongs to the converter panels, and the second is the control panel of the turbines. In the control panel, we have a PLC which control all the turbines and their input output logic cards. And in the converter panel, we have a independent converter system which control the generator unstabilized energy and convert it to stabilized energy, the function of this converter. So let's visit and check all the panels one by one. This is the converter panel, and we have install here the converter module which control all the converters function. And then okay, this direction, this is the Nodex control panel which control the turbine. We have a PLC here. You can see on the top, if you can see my mouse, this is an NFC, the main PLC of this turbine. And these are all the card of this PLC which give us input output information, and also give us the analog values and analog output and digital input and digital outputs. And we have other breakers as well here which control these breakers are belongs to some breakers are belongs to the fan of this turbine, some belongs to the pump, because you can see here we have a cooling unit, and it's required the power to start. So we have some breakers and some other switches here, and we have some contactor. And also you can see on the bottom that we have here a UPS, and there's a small transformer here. The function of this small transformer is we have a 660 supply voltage in this turbine, but all these other equipment, auxiliary equipment, required a 400 or 240 supply. So these transfers convert from 660 to 400. Okay, let's go for the other panel. Okay, it was the panel which I show you, which we call the Nodex panel, actually the bottom side. In this panel we have a one computer, we call it personal local computer. And with the help of this computer, you can it's like a HMI, you can operate the turbines. And this is the main computer which is sending this data to the RSCADA. First, RSCADA data is being stored in this local computer, and then on the daily basis sending to RSCADA as well. And there are some switches here, I will also show the function of these switches to you. Okay, first, when you enter the turbine, please turn on the light, and then you have to check the fire extinguisher system. After checking the fire extinguisher system, please lock the door. And the best thing about this door, it can only open without key from inside the turbine. If you're coming from outside, there is no option to open the door without key. From inside, it can open easily. And okay, it was there are some switches on the panel which we see here. The function of this, there are some buttons here, and there are some lights. These lights indicate some kind of error and abnormality, and if turbine is normal or not. This indication, like the installation error, safety error, and if turbine is automatic mode, the number 4 light will blink start, and the grid coupling is connected with the grid or not, and there's some kind of errors. These light indicates us the information about the status of the turbines. Also, we have some kind of switches here which help us to make a turbine local and remote. Also, we can start turbines with small buttons. We can reset the turbines as well. And we have a small uh, emergency switch here. When we press this switch, turbine completely shut down. Okay, let me close it first. Okay, it's a converter frame. Okay, So there are two options to go inside the nacelle. Either you can use this ladder. In this ladder, we have a fall arching system in the center, and we use the Haka ladder. And the other options, which we mostly use, we have an elevator in these turbines. So before using the elevator, you have to perform some test. So let's check what kind of test you need to perform while running the elevator. We are using different kind of service lift in our turbines. It could be Zorgas, from Zorgas, or Hilo. We are using two different kind of manufacturer, but this video is belong to the Zorgas one. So before entering the service lift, you have to use your Hakka. You have to use your lanyard, and then you will release a lanyard from outside, and then you have to perform some tests before using that. Please check the seal first. If everything is okay, if the seal is broken, you are not allowed to use it, because it might be someone make some changing, and it could be dangerous. After checking the seals, you have to use a daily log sheet, and you have to fill that log sheet that everything okay. Why you need to fill this log sheet? Because this is only necessary to perform this test once a day. If someone has already visited and performed this test, then you don't need to repeat this test all the time. Just once a day is enough. So you have to check the states. When the inspection is not expire, then you have to perform some safety tests. This is the OSL device, over speed locking device. In case of your lift is coming down speedily, and so this locking device will hold your elevator and will not allow you to fall down directly on the. So this is the safety system, and we have to perform some kind of test while we are using the elevator. Then we have to test by hand that in case of the elevator is coming freely, is this OSL work or not? By the pulling this cable, we check this function if it will work or not, and then we also check the function of the motor and everything. Let me go with it first. If someone has any question regarding the service lift, so you can ask me right now, and then we will, because I have to close this after that.
I don't see any questions so far, but I'll let you know.
Okay. This is while you are performing the test, there one more test that you have to check the centrifugal force of these OSL device. If something is rotating in that device, it means it's working fine. If you don't see any movement in the device, then you have to stop the lift there, and you don't need to use it anymore. And when everything is okay, then you can use in the whole day without testing it again and again. This is the procedure from Zorgas. Ready to operate. Then when we mark it ready to operation, and then we can use it. Okay, now let's visit the nacelle. Okay, we can either use the ladder and elevator lift as well. So let's come inside the nacelle. Okay, now we are in the nacelle, and there are too many components are in the nacelle. We are currently standing on the gearbox. This is our gearbox, and after the gearbox, we have coupling, and after the coupling, we have a generator. So let's check all the component one by one.
Bilal, before you begin, we have a question in the chat.
Yeah.
About the maintenance. So Alex asked, what are the most frequent incidents during operation and maintenance of the turbines?
Okay, actually, as I mentioned in my start, that's if you talk about the old turbines and the new turbines, they are different, because our new turbines, we only need to perform the maintenance once a year, and also the task of the maintenance is very less as compared to other turbines. And also there are some old product we are also making maintenance once a year, but it's also depend on the location. Like if I talk about Pakistan, in Pakistan we have too much dust, and due to dust, our filters and other component is starting to heat up very early, so we have to perform the maintenance twice a year. But in some other countries where we don't have too much dust and other factors like temperature, dust, we have too much temperature in Pakistan as well, so we are only performing the maintenance once a year. I think this is what Alex was asking, right?
Yes, I think it's good. You can continue the tour, please.
Okay. So let's start from the most. We have this gearbox. This gearbox has two planetary stages and one halo stages, and we have a hydraulic unit here. Here we can check all the description after clicking this, but it will take enough time because when I click on this, it will show us the information about the gearbox structure. Let me show you that how it's showing. It show the video regarding the gearbox, how it's inside. And as I mentioned that it has a different two planetary stages and one helicoid stages in this gearbox. These gearbox could be from different manufacturer. We are either using the Rathrox, now they are currently ZF, and it could be either Wing Energy or ICOF. We are using a different kind of gearbox in our turbines. And we have a hydraulic unit here. And this unit, we are using hydraulic unit just for braking system of the router and also the braking system of the yawing. I will show you the yawing system during our animated video. So we are using this system only for two purposes here. In some new models, we have a pitch hydraulic pitch system on hydraulic system. So we are also using hydraulic system to support to move the blade. But in this model, we are only using this hydraulic unit for the braking system on the router and also the yawing braking systems. Also, let's go there. At the end of a nacelle, we have a trafo box here. I show you inside the picture of the trafo box as well. And we have a aviation light box inside the turbine and the CMS box, the condition monitoring system. It's check all the main components all the times and give us the information if someone is going to damage us, if anything is going to damage early. Also, we have a different kind of panels here. Like we have a, let me open this. Okay, let's go. Okay, it's showing us some picture and asking, you use the isolated glove. Okay, right. And the next question is going to ask, which class isolated gloves shown in below in the suitable? So if someone observe the gloves, can tell me the right answer. If not, then I will select.
So in the chat or ask permission, do you know which class to use?
They can mention in the message as well. It's fine. Okay, now I select. Actually, those class is belong to the 0 to 1000 world class. Yeah, my answer is correct. Thank you. Okay, we are inside the panel right now, and this is a instruction, and it must be, because before you starting the work on any electrical component, you have to apply the LOTO, logout tagout procedure. This is really important. So this is really good, and we also implementing all industry are implementing this procedure. Are good industry. Inside this panel, you can see there are some breakers. There are some breakers here, and also we can see here there are some introbus Profinet cards. These cards belong to the PLC system. Actually, we have seen some cards inside the bottom panel. Those cards are only taking information from the auxiliary system, which is inside the bottom panel. But the input output cards are taking information from the nacelle. There are many auxiliaries in the nacelle as well, and these breakers also providing the voltages and the source to other auxiliary things like a motor, pump, and fans. There are many fans inside the nacelle, so it's providing the power to them. Okay, let me open. Okay, I go back there. As we have seen, there's some kind of lights in the bottom side. The same system we have in the nacelle. We can use this system to operate to control the turbine from the nacelle. If you don't have laptop and you don't have a laptop to connect with a SCADA, then you can use these buttons and some lights. These will give you some information about our turbines. What is the condition of the turbines? in which state the turbine is right now. You can also reset the safety system and the other function we can use with the help of these buttons. Also, we have some indication lights in the nacelle in the Delta 3 turbines. These lights also give us information with the help of hooter and the condition of the lights. For example, if we have a fire inside the turbine, so then hooter started to give us noise, started to make a noise, and also the green, yellow, and red light starting to flash together in this condition if you have fire inside the turbine. And in the other condition, if you have any safety critical error, it will not horn all the time. It will not horn all the time. Only 2 short tunes every minute, and the only green and red light will blink. And if you have a high wind, too high wind, and we are working in the nacelle, here I would like to add you that in the tubular tower, if you want to work in the nacelle, then your wind speed must be less than 20 meters per second in the 10 minutes average wind speed. So if you are working here, and if you have high wind, more than high wind, then you will see that green and yellow light is started to flash. This was the information. Let's go outside and visit the hub. Now this is a way to go inside the hub, the router, the rotating part of the turbine. But before going inside the hub, you have to make a lock, because the hub is all the time rotating, and you have to lock the hub before entering the hub. You have to lock it. There's a procedure. How you can, let me show you.
Bilal, we don't have a lot of time, so maybe we can.
Yeah, okay. Let me do fast. Actually, yes, this is a problem. We don't have enough time. Okay, just going to back. With the help of this pin with ruler, you have to move it, and the pin will go inside. And when you see there's a green tape here, it's mean you're ready to go inside. This is only the indication. Now let's go inside because we don't have enough time. I'm going inside here. This is the where we come inside. Now we have a question. What is the permitted maximum wind speed limit for working in the hub section? Because as I told you that we have a working wind speed in the nacelle, it was a 20 meter per second for 10 minutes average. But we have 3 options here, and because we don't have time, then I have to select the right one myself. It's 12 meter per second. Yeah, I'm correct. Thank you. There are some components also inside the hub. We have a pitch drive. Each blade has an independent pitch drives, and we have a skip hatch here. In case of fire, we can use this hatch to go outside, and we always carry some kind of rescue device with us, and with the help of those rescue device, we can go outside from this. Yes, Umar Raja, yes, it's a 12 meter per second, the correct answer. He has mentioned answer inside the yes. And we have each pitch drive, we have an independent control system. Like we have a pitch box, and we have a backup batteries. And we have a central box here. This central box also contain the logical input outputs modules. Let's go back inside the nacelle. Here I would like to just ask if someone has any questions, then I can only focus on that one. Because we don't have enough time. If no, then I will finish it here and show some other information.
I had a question by Dia, who was wondering if the web page is available so they can take this tour, virtual tour again. If yes, what's the name or the link of the website or the place to access?
You mean to say you want to access, then you can use this link. I'm copying in the message as well, so everyone can access. Okay, that's really good. I send a message in the link. I think everyone has received my link, right? Okay.
Yes, thank you. Do we have any more questions before we wrap up?
If no, then I will share. I know it's time. We don't have too much time, but if not, then I will want to also share some small information here regarding the youth, because now we have a session regarding the youth. So I would like to mention about the Nodex. Currently, more than 8,000 people are working with the Nodex, and 20% of them are under 30 age, under the age of 30 years, and between 30 to 50 years age, we have a 66%. right now. And we have too many women, like 16% women are also working with the Nodex as well, and 84% are males working with the Nodex. Here, what we have that if you are a working student, you can visit the Nodex website, and on the Nodex website you will go for the career. On the career, you will find there are many jobs for students as well. If you are a student and want to learn about the Nodex, so there are many jobs available for students as well on the Nodex forum for youth as well. So you can visit the Nodex forum, and if you have any, does Nodex has a special policies to attract more young people and women? Actually, in Nodex, there is no discrimination, so everyone is welcome, either is a male or female. So as a male, this is also good for us. So there is no discrimination. If you are a woman or man, everyone can join the Nodex without any discrimination. Even though the women are working on Turbine as a technician as well in the Nodex. So yeah, this is really good. If you want to work as a technician or a technical person, you can join. Either you are a woman or man, does not matter in the Nodex as well. It's really good. So Linda, I finished because I'm already 5 minutes over from the given time. Thank you for your giving me time too much. Okay, let's me finish, and then you can finish right now.
Okay. So thanks everybody for joining. There was a last really small question from Nimal. At what speed do you lock the turbine? And another quick question, does Nordex offer jobs in Egypt? If you can take those quickly, and then I'll finish the session. I'm sorry, we don't have more time.
Oh, right now, we don't have any project in Egypt, but Descon is offering the people from Egypt. If you are a technical person, you can join the Nordex and you can come Germany and any other country as well. It does not matter, because we have a service station around 32 countries, but more than 73 the people from more than 73 countries are working with us. So it means that Nordex is not everywhere in the 73 countries, but the people from different countries are working with Nordex. So everyone from different countries can join the Nodex. It's an open vacancy. It does not matter they need only a person from Germany or Pakistan. Everyone can apply, and if you select it, you can join Nodex in Germany, in Turkey, and everywhere. So it's open platform for everyone. Anything?
There was a question, at what speed do you lock the turbine?
Lock the turbine means you are talking about the hub or stop the turbine. Normally, if you're talking about the stop the turbines, the wind speed from 3 meter per second, we can produce the power from 3 meter per second to 25 meter per second. And after 25 meter per second, turbine will shut down. And if the wind is increasing, turbine will move its direction 90 degree opposite the wind gust. This is the procedure.
All right. I guess that's it. So thank you everybody for joining. Thanks for your questions. Thank you, Bilal, for this lovely presentation. It was really nice. And so if you want to do the visit again, Bilal has shared the link in the chat, so you can see everything at a slower pace. And I'm gonna invite you all to go back to the main stage for the closing. Thank you, everybody. And see you soon. Hope you enjoyed Youth for Beth.